Hi guys, welcome to section 9.1. We're going to start into chapter 9 and start talking about reflections. So we talked about those vectors. We're going to hold on to those for just a day. We'll use those tomorrow when we talk about translations. But reflections first. So we're going to draw images and their reflections. We're going to do a lot of coordinate plane work in this whole chapter. And first of all, you probably know that a reflection is a transformation. We didn't talk about that. The main kind of transformation is the main name for different things that you can do with images on a coordinate plane or not. So a transformation that represents a flip or a mirror image. Makes sense, right? Reflection, mirror image. Each point of the pre-image and the image are equidistant from the line of the reflection. You can see in the example that I've got here on the board that C and the C, we call it C prime. It's got C prime is a little apostrophe or one superscript. So C and C prime are a reflection and they're equidistant from that line K. You notice B and B prime are reflection and they're equidistant, and A and A prime are equidistant. We will do three different types of reflecting. We'll either reflect over an x-axis, so our vertical or our horizontal axis, our y-axis, or our line y equals x. And that will be the line of reflection. So I'll say, reflect the image over the x-axis. So the x-axis is our line of reflection. We do need to talk terminology. We've got a pre-image and an image. The pre-image is the image before the transformation. It's the original. The image is our resulting figure after that transformation. So after we reflect it, we've got an image. Before we reflect it, we've got a pre-image. I always know by my points, this is my pre-image because it's got the regular ABC. This is my image because it's A prime, B prime, C prime, triangle, A prime, B prime, C prime. So our image is after that reflection. Reflection has congruence. It is a congruence transformation, which means that the image is congruent to the pre-image, even though the position may change. We're going to find several transformations that maintain congruence. We also use the word isometry for that. If I say that it's isometric, that means that our image and our pre-image are congruent. So they can go all over our coordinate plane, but they're still going to be congruent. So let's talk about our rules for reflecting. So we can do three things: reflect over the x, reflect over the y, or reflect over the line y equals x. So here's our x-axis, here's our y-axis. So under the reflection in the x-axis, it says to reflect a point in the x-axis, multiply its y-coordinate by -1. So in other words, our xy ordered pair, if we're going to reflect that, it's going to become x with a negative y value. Now we know if we multiply by -1, if it was already a negative, it becomes a positive. So my reflection over the x-axis, if I start with this point A that you can barely see is the ordered pair 4, 1, common sense tells us that it'll be right about here, equidistant on the other side of the x-axis. Common sense tells us that B will be somewhere around here. But my ordered pair for A prime, reflected over the x-axis, should be 4, -1, over 4 and down 1. So I take my x-coordinate 1, and I multiply that by negative. So my B prime will be my same x-coordinate and the opposite sign on my y-coordinate. So that should be B prime should be 7, -3. And we could draw that so that our line is reflected, segment AB is reflected over the x-axis. Reflection over the y-axis In words, it says to reflect a point in the y-axis, multiply its x-coordinate by -1. So if we start off with any random ordered pair, xy, our reflection over the y-axis, multiply the x-coordinate by -1, so it will be -x, y. So I've got this point A over here in quadrant 1. A is at 2, 3. So my reflected point over the y-axis will be a reflection. If I fold right over the y-axis, it would land right about there. That's going to be my A prime. And the ordered pair for that A prime will be opposite sign of my x-coordinate, same y. So that should be a -2, 3. Makes sense. Back 2 and up 3. My B coordinate, B prime coordinate, will be somewhere down there. It starts off as 6, -4. So my ordered pair for that should be -6, -4. Notice, whoops, -6, -4. Notice the only thing that changes is my sign on my x-coordinate if I'm going to reflect over the y-axis. Seems pretty simple, right? So I'm going to ask you to do something like this. It says to sketch triangle KLM. That is our pre-image. The vertices are those ordered pairs. Its image wants to be reflected over the y-axis. Compare the coordinates of the pre-image and the image. You can kind of do this in any order. Go ahead and sketch that. 2, -4 for my k. Please label your points. I don't know where k and k prime are unless you show me. L is at -1, 3. And M is at -3, -2. So here is my pre-image triangle KLM. I'm going to reflect this over the y-axis. So the rule for reflecting over the y-axis is my xy ordered pair ends up being -x, y. I don't know if it helps you to remember, but reflect over the y, change the x. Reflect over the x, change the y. So it only makes sense if you look at L, point L. If I'm going to reflect that, fold on the y-axis, it looks to me like L prime should be at 1, 3, which makes sense for my rule, which is multiply the x value by -1. My k value over here in quadrant 4 ends up being equidistant in quadrant 3. So that'll be my k prime. When I look at that, -2, -4. Oops, that's k prime. And my M point that is over here in quadrant 3 ends up getting reflected over in quadrant 4. So that should be 1, 2, 3, 2, right about there, I think. M prime. It's okay for our image and our pre-image to overlap each other. If you want to find the ordered pairs first using the rule and sketch them after, if you want to sketch and see the reflection and then put in the ordered pairs, it all gets down on paper one way or the other. All right. This next one, I don't think we need to talk too much about it, but it does say that we're going to reflect over the x-axis. So the rule is reflect over the x-axis, change the y. So I'm just going to change my ordered pairs, only the sign on the y value. I think we're okay with not doing that. If you want to, we can. So last but not least, we can also reflect over the line y equals x. If you think about the line y equals x, if x is 1, y is 1. If x is -2, y is -2. So it is this diagonal line that goes through the origin with a slope of 1. So to reflect a point in the line y equals x, interchange the x and y coordinates. So in other words, my xy coordinate becomes a yx coordinate. So up here, I've got a point A that is at -5, 2. So point A prime is going to be at 2, -5. No sign change, only the ordered pairs switch. If I'm going to find point B prime, my B point, my pre-image is at -1, 4. So my B prime has to be at 4, -1. So it should be right about over 4 down 1. Right about there, I think. Did I do my A? over 2 down 5. This one starts to get a little bit harder to see when you want to just eyeball and figure out where does point A prime or B prime go, because it's got a different slope and it looks different. So using the rule on this one is probably the better option. All right, so let's do this one. It says to sketch that same triangle. So K is at 2, -4. L is at -1, 3. And M is at -3, -2. Draw our triangle in. Not a very good triangle. There's our pre-image. The rule for y equals x. Ordered pair becomes yx. So my K prime should be at -4, 2. My L prime should be at 3, -1. And my M prime, -2, -3. Hopefully you've all picked up on the idea when I write it out this way. That's what I'm looking for from you as well. So please write out what are your ordered pairs for your K, L, and M primes. Sketch it if it asks to sketch it. So K prime's at -4, 2. K prime. L prime's at 3, -1. And M prime is at -2, -3. The trickiest part is sometimes they start to be the same point and you got to figure out what's where. So this light blue one is my reflection. If I put a nice neat line, y equals x, can you see that L and L prime are reflections of each other over that line, y equals x? So if you have that line in there and you want to use that to eyeball that point, you could give that a try, kind of using slope, but or else just get the ordered pairs and then put that on the graph. So that is it, those 3 different reflections in section, in section 9.1. That's it. Have a great day. We'll talk to you next time.